Hello, my name is Sahil Mehta, and today I'm going to be talking about my ENME435 remote sensing final project. In this final project, we were tasked with the goal of using remote sensing concepts and a LiDAR scanner to generate a 3D point cloud of a target on campus. Let's first talk about some remote sensing concepts. Remote sensing focuses on techniques that help the users detect a given target by using a radiation source and a receiver or detector and acquiring data about the target. From there, we can use code to analyze and interpret that data. In the case of our project, we are using a laser as a radiation source, a Pi camera for our receiver, and a Raspberry Pi with Python code implementing the OpenCV library to control the system, acquire data, and generate our 3D point cloud. Quick note, but LiDAR is actually heavily used in industry like in autonomous driving, and topography mapping. Going back to the target, I picked the Brendan Iribe sign as a way to commemorate the years I spent as a computer science student. I pass by it every day when I go to classes, and I wanted this way to show how much the school meant to me, so I picked this as my target. To build our system, we 3D printed a mount for our laser and Arduino, Raspberry Pi, and Pi camera. After readjusting the hole for the laser, we put it all together and to get this system right here. The Arduino powers the laser, and the Raspberry Pi powers the Pi camera, does all the computation, and sends any information back to the user. Now, having built our mount, we need a way to calibrate our system to start scanning. By looking at this visualization, the values we are provided are PFC, or pixels from the center, and H, which we know to be 12 inches from the mount. The unknowns are D and theta. And by using basic trigonometry, we can determine that D is equal to H divided by tan theta. This makes sense since as our target gets closer, the farther the target appears in the picture because of the tan theta term. So, to solve for theta, we need to convert the PFC value to radians by tuning radians per pixel pitch, the value RPC, and the radiant offset value, which will help us create theta. After collecting alignment images shown here, we script that uses a color mask to focus on the red pixels in the image, locate the line in the image, and plot the PFC distance relation. We then adjust the RPC and RO value to get a curve that fits those data points. With this curve fit, we did a quick test on a personal item, in which case I did a cart. Note that I 3D printed a mount like this, connect my LiDAR mount to a tripod. Additionally, while not shown here, since I am holding my phone to record the video, I used an app on my phone to find the tilt angle of my tripod that would then be used in the script to collect pictures. Knowing that my scan of the personal item worked, we moved on to a test scan of our target. As you can see, my setup is working perfectly fine, but note that there's a bright light shining behind my target, which is going to cause problems down in the future. Having scanned the front side of our reap sign, we then use the Python script datageneration.py to process these images as you can see here. The script then uses the masking feature to find the laser on my target and generate a 3 point cloud. This is me running the script right here. This is the test results txt file that has our 3D point cloud. This is the matplot visualization of the 3D point cloud. And finally, this is the cloud compare version of my 3D point cloud. As you might note, the front side scaled very strangely, and me and the professor determined the issue to be micro adjustments in the laser as I brought my LiDAR scanner to the target. So, we had to fix this. To fix this, I decided to calibrate on site, generating this new curve. From there, we continue collecting data from all sites, as shown here, where I'm collecting data from the left side. As you can see, there's still that whole brightness issue that we'll have to deal with, but that's for a later point. And after having done all this, we process all sides through the script to generate point clouds for all sides. One thing we have to handle was the brightness, making the color mask not as effective at separating each of the laser from the light and the target. To fix this, we implemented different color masks, as you can note here, as well as control statements down the line, right here, to change the mask during the conversion process to better separate the noise from the laser. From there, I put all my point clouds into the cloud compare software as shown right here. I remove as much noise as possible and generate a final point cloud. As you can see, I'm able to move a submitted point cloud onto the software, and I use that feature to now generate my new final 3 point cloud. This is in the video, as you can see, it's not as fully updated, but the submission will be. So update here from Future Sahil. As I mentioned, there was going to be a submission version, and this is the submission version. As you see, it's quite a high quality point cloud. It shows the kind of the curve that we did and eventually see with the Arif sign. Has both all the front side and the back side. Most of the noise has been cleaned up. There's a little bit, but it's quite high quality for what it is, and it has all sides ready to go. So this is the final submission. That does have color, but you can remove the color. But yeah, this is the final submission. After finally having created my final point cloud, I then use the 3D mesh software on point cloud to generate a mesh. This mesh, while a bit messy, does resemble the shape of my target, the feature and the featuresque of the sign, showing that I created a relatively high quality point cloud of the IREP sign. As you can see here, there are a few blobs that I have, but I'm able to remove them using segmentation, and so you can still see that we are able to get the featuresque of my sign. This project taught me a lot about new technologies like LiDAR and through cloud compare softwares and all the different remote sensing topics. I'm glad I was had a chance to do this. Thank you.